The Alldus podcast is brought to you by Alldus International, supplying your expert AI and digital transformation staffing needs across the US and Europe. Today, you are listening to our AI in Action series, where leading minds in AI from across the world share their story, success, and advice. AI in Action cuts through the hype and explores the true impact of artificial intelligence in our world today.
You're listening to AI in Action. I'm your host, JP Valentine. Our guest today is Keshav Pingali. Keshav is the founder and CEO at Katana Graph. Keshav, welcome to the show.
Good to meet you, JP.
Yeah, we're delighted to have you on. So, Keshav, let's start with yourself. Can you give us a bit of a background of your journey in technology, from where you got started, some of the roles you've held along the way, and what's led you to where you're at today?
So I got my PhD at MIT. After that, I was a professor at Cornell. And about 15 years ago, I moved to UT Austin. During my research career, I have worked in high-performance computing. But about 10 years ago, a group of colleagues and I realized that there was an opportunity to take everything that we had learned in high-performance computing, which traditionally has been used for simulating physical phenomena, for designing aircraft, things like that. Take all of those technologies and then use them for high-performance graph computing. And so for about 10 years or so, I've been working in that area. Our research was supported by DARPA, several DARPA projects. And one of the DARPA projects we did was with BAE Systems. So BAE Systems approached us because they wanted to build a system for real-time intrusion detection in computer networks. And they wanted to do that using an approach that's called Provenance Graphs. So you build a big graph of various information flows in your computer network, and then you look for forbidden patterns in there. So for example, if every conversation or communication between you and me needs to go through my office assistant. In that case, you say, is there a path from my vertex to your vertex that doesn't contain my office assistant's vertex? And if so, you raise a flag and a human operator steps in. So DARPA really liked the system that we built, and they encouraged us to do a startup. They offered to introduce us to various three-letter agencies if we did it. So that's how Katana Graph started about 2 years ago.
Amazing. What a great backstory to what is now your current company, Katana Graph. A great origin story of an idea and the demand and now the backing and support. So Katana Graph is the name of that startup. Please tell us all about Katana Graph. What is the mission of the organization and what has the journey been like over the past 2 years since the formation of the business?
Yeah, it's been a really exciting journey. So what our mission is to enable just about anybody, but data scientists in particular, to extract insights from very large amounts of unstructured data. So we want to enable them to do it easily and also get these insights fast. So there are two parts to the argument about why the technology that we're building at Katana Graph is going to enable this particular mission. One having to do with the volume of data and the other having to do with the time to insight. So there are two parts for this argument. So the first one has to do with just the amount of data. So we're all familiar with these terms, data tsunami and data deluge. And what these terms mean is that the world has generated a tremendous amount of data, and the rate at which we are generating new data keeps increasing all the time. A lot of that data is what we call unstructured data. So it's data that can be usefully represented in many cases as a linked data structure, as entities and relationships between those entities, and then processed or analyzed using what we call graph algorithms and graph AI machine learning. So that's one part of the argument for why we need the kind of scale-out graph technologies that we are building at Katana, the sheer volume of data that needs to be processed. The other part of the argument has to do with time to insight. So in many use cases, such as this use case I mentioned to you about intrusion detection in computer networks, The sooner you can catch the bad guys who've broken into your network, the better off you are, because you want to catch them before they do any significant damage. So time to insight is also very important. So if you put these two things together, the volume of data, in particular unstructured data that we believe can be represented usefully as a graph, and the need to process all of this data very fast to get insights into what's happening, that argues for the kind of platform that we are building at Katana, which is a scale-out platform. So it scales out to more than 256 machines, which is a very large number of machines. And you can do querying, you can do AI, you can do analytics on data at that scale.
My follow-up question to that is just to understand potential use cases for you and for your customer base. And obviously, with the backing and support and the proof of concept that you have, it's quite powerful as it is. Who's using Katana Graph now? And speaking to an audience of data professionals, what are the possible use cases that Katana Graph can have a significant impact on advanced data and analysis?
Yeah, JP, that's a great question. Let me tell you about a few verticals that we have engagements in currently. When I started, my main mentor, Libu Tang, who's CEO of Cadence, he also has his own venture fund. So the advice he gave me was that as a startup, the hardest thing for a CEO to do is to say no to opportunities. And I didn't quite understand it at that time, but now I understand exactly what he meant, because you have to focus. Lots of opportunities come your way, and it's very easy to get distracted and run around in many different directions and not really make an impact in any one direction. So right from the beginning, Chris Rosbach, my co-founder, who's CTO of Katana, Chris and I decided we were going to focus on certain verticals. The three verticals that we picked, one is medical and pharma. And I'll tell you a little bit about some of the work we're doing there with some leading companies in those areas. The second area is fintech, banking. So we're getting a lot of traction in that space. And the third is in what people now call InfoSec, or information security. And we've already alluded to the earlier work that we did before Katana with BAE Systems on real-time intrusion detection. So there's a lot to be done. Let me give you two concrete use cases in the medical and pharma space. So we have a contract right now with one of the biggest pharma companies in the world. And what they have, every other pharma company, is what's called a big medical knowledge graph. So this is a graph in which you have information about diseases, potential treatments for diseases, viruses, proteins, bacteria, living organisms, papers that have been published, authors. So just a whole lot of medical knowledge that is represented as a graph. And a graph makes sense for representing all of this information because, for example, if you're talking about a paper that's discussing a potential treatment for COVID, so then you would have a node in the graph for the paper, nodes for the authors, a node, an edge connecting it to a node representing COVID, and so on. And people have medical knowledge graphs. And what this company is interested in doing is what is called hypothesis generation. The idea is to be able to, given a disease, can you generate, by looking at the medical knowledge graph, potential treatments for that disease? And equally importantly, can you also rule out certain potential treatments for a disease? Because it's a lot cheaper to do this on a computer, right, in maybe a few hours by mining the medical knowledge graph, than going to a vet, doing the experiments, and then finding out that something really doesn't. And they're interested in, this is called hypothesis generation. So if I have COVID, there's a lot of discussion now about whether ivermectin is a useful treatment or not. So that is the kind of query that they want to give the medical knowledge system that uses analytics, machine learning, and so on the medical knowledge graph, and then get back these answers in a reasonable amount of time.
That's an incredible use case. We do a lot of interviews with people in the pharma biotech world, and the biggest pain point is the disconnect between the medical knowledge and the tools available to help these people do what they're best at, which is focus on the medical knowledge. And you guys are bridging that gap with an exceptional rate of speed and accuracy. So that's very powerful. Similarly, then, I'd love to just use it as an opportunity to talk about one more example within the fintech world, because they're two very different problems and data sets, but the use cases also really speak to the impact. So please do, if there's an example that stands out within the banking and fintech world, it'd be great to hear.
So we currently have a contract with one of the biggest online payments company in the world. So they have a lot of financial transaction data. And what they want to be able to do, because this is all online financial transactions, basically credit card transactions and things like that, they want to be able to identify potentially fraudulent transactions as quickly as possible. Now, there are many ways to do it. So there are what I'll call old-fashioned AI, right, if you know that. So rule-based systems that say, if this person, let's take everything we know about this person, and if it looks like he's making a purchase of more than $100,000, but annual income is only $20,000, then we need to look closely at it and so on. So those are rule-based systems, which was the old way of doing it. The new way of doing it, which has turned out to be more accurate again, is to build a graph in which you represent everything that's known about the financial transactions that have gone on in the past. And so in this graph, you will have nodes corresponding to people, nodes corresponding to transactions, items that they bought, accounts that they have, and so on. And every time a transaction happens, you add more nodes or more edges between existing nodes and so on. And then the idea is to be able to look at this particular graph and then identify potentially fraudulent transactions, or perhaps, for example, money laundering. Sometimes they're also called fraud rings, because very often people have a chain of dummy accounts through which they're funneling money and so on. So the basic idea is, again, you build a graph to represent all of the financial transactions that have happened in the past. And then given a new transaction, you want to make a prediction for whether this is possibly fraudulent or not. So this is another example where, going back to why we need a scale-out graph platform like the one that we have built at Katana, we talked about the volume of data and we talked about time to insight. And in this particular use case, you actually see both, because there is tremendous terabytes of information, if not more, about transactional data in the past. So you need to be able to process that scale of data. And the company that we are working with tried other systems that are in this space and found that just ingesting the data would take, even after 24 hours, they were not able to ingest all of the data they wanted to ingest. Whereas with Katana, it just took a few minutes. And so they were able to ingest the data very quickly. And then they were also able to do all of the analytics and AI very quickly.
You are listening to the Alldus podcast. When you're looking to scale your team, or if you are interested in showcasing your company in a future episode, reach out today. Or if you're in the market for a new role, visit our website to view open positions, www.alldus.com.
You referenced Katana's AI platform and the speed and power. I want to spend a bit of time now just on the technology behind all of this, because the impact is clear and obvious. It would be great for our audience, who are all technology professionals, data professionals, without giving away the secret sauce, of course, but can you give us some insight into what it's like behind the scenes, what it looks like day to day or on a particular project for the engineering team, from concept to implementation and impact? What's the typical journey like, and what it's like to be part of the team here?
So first, about just a high-level view of the technology. If you open up the box, what do you see inside Katana? At the heart of our system is what we call the Katana Graph engine. And what it is, in-memory graph computing platform. The branding that we have done for Katana is we are building a graph intelligence platform. And so the key words over there are graph, intelligence, and platform. So what does platform mean over here? Well, what it means is we have this scale-out solution which can compute on extremely large graphs very efficiently. So the way that you would use our system to do processing of some graph data is you point our system to the graph, which is sitting in, let's say, AWS S3 buckets. So we are cloud native. We run on all the three public clouds. We also have on-prem installations. So if you're running on AWS, you point us to where your graph data is sitting in secondary storage somewhere, blob storage, whatever. What Katana Graph Engine will do then is if you tell it how many machines you want to run this particular graph application on, it will read in the graph data from S3 buckets, and then it will shard the graph or partition the graph. So it's like taking scissors and then cutting up the graph into pieces so that each piece can then fit into the memory of one machine. Okay, so that's called sharding or partitioning the graph. And we support a whole lot of different partitioning policies, unlike many of the other systems in this space. So we have a partitioner that's called CUSP, and you can actually write your own partitioning policies if you want to, but it also comes with a whole lot of canned partitioning policies. So once CUSP is done, you've taken your graph data and you have sharded it and you've loaded it into the memories of a bunch of machines. And as I was telling you, we're a scale-out platform, so we've tested it on up to 256 machines, and we could go even larger than that if needed, but it gets very expensive on the cloud as you add more and more machines. Once you've done that, then we have an in-memory compute engine that's called the Galway compute engine. So it's a collection of data structures and a library of data structures and a runtime. And what it does is it performs whatever graph computation you want on the particular piece on a single machine. Now, anytime you partition the graph, you have to worry about what happens at the boundaries of the partitions. You have to make sure that everything is synchronized properly, as we say. So that is done by a communication runtime that we have also built that's optimized for the needs of graph computing. So these are the three pieces. So you take the graph that's sitting in secondary storage, you shard it or partition it between the memories of a bunch of machines. You get to specify how many. Then each of the machines computes for a little while on its piece, and then they exchange information to make sure that everything is synchronized. So this system is built in C++ because performance for us was very important. So unlike other systems in this space that are built on Java, managed languages like that, we've gone with C++ for better or for worse, right? So we get very good performance that way. What we've done on top of it is to build libraries for different applications. So we expose the functionality of this graph engine, the scale-out graph platform through both C++, so you can write C++ code, but we also allow you to orchestrate the graph engine from Python, because increasingly in data science, Python is it.
That's the language
they
of
don't
choice.
see C++. So you can program in both Python and C++. We give you certain constructs that our system understands. You have to use those, and then we take care of the rest for you. So what we built on top of this then are libraries for doing analytics of various kinds. So just to give you one example of something that we're building for a three-letter agency in Washington, it's called Betweenness Centrality. So given a graph of actors, let's say terrorist actors, for example, you want to find out who the main guys are, right? And so there is a graph computation that's called Betweenness Centrality that's used for this application. So we have our own Betweenness Centrality algorithms that we have developed, which are very efficient. And then those we can implement on our graph platform and then make available to people who want to do it. So that's analytics. And then the last part of it is in graph AI and machine learning. So as we've been talking about, there's a tremendous amount of interest in graph convolutional networks and graph neural networks and so on. So we have our own implementations of those. We also interoperate with PyTorch geometric. So one of the nice things about our platform is that it's very easy to integrate in a native way with third-party libraries like PyTorch geometric. So that's more difficult for other systems in this space that are really graph databases, right? So for those systems, if you want to interoperate with PyTorch geometric, then you have to allocate a new cluster, send data over there, bring data back, and so on. Whereas for our system, because we're a platform, all of this integration is seamless. And in fact, we routinely use PyTorch geometric for some of the things in graph AI and machine learning. And then the final part is we have a graph database that we have built. And we support the OpenCipher, which is a query language that was popularized by Neo4j, and we really like it. And there's a new graph query language called GQL that's becoming a standard, so we will support that as well. So a typical use case then for some of our users is you have this big graph that's sitting in secondary storage, And then you want to extract a subgraph, a smaller portion of that overall graph, and bring it in for analysis. So that is done using the query language. So the query will basically return a subgraph to you. And then this subgraph gets sharded between the machines, and then you compute on it and so on, and you return the results. So those are the kinds of, in more detail, use cases, right, that we were talking about earlier. That's how the implementation is done. Now, in terms of our team, which was the second part of your question. So at this point, we have about maybe 90 people in the company. And we did our Series A in March of last year, and we raised 28.5 million. The Series A round was led by Intel Capital, because we have very close ties with Intel, research ties going back many years. But they're also interested in becoming more of a software company, as you probably know. And so they're very supportive of everything we've been doing at Katana. Dell Venture Capital is another company that invested in Series A. So Michael Dell approached me when we were almost done with Series A and said, hey, I heard about Katana. He was from UT Austin, as you probably know. And so he said, oh, we'd like to invest. And so, of course, we made room for him. We raised 28.5 million last March, and that's enabled us to grow very fast. So back then, I think we were about 25 people or so. So we've really expanded a great deal. Of the 85 people or so we have at the company, I would say about 60 are engineers, and the rest of them are on the business side. So I kept the expansion of the business side slow, because until you have a product and the engineering gets to a certain point, it doesn't make sense to hire a lot of salespeople and so on. But now we've reached a point where we've actually shipped the product to some of the customers I was telling you about. And so now we're in the process of doing a Series B. And post-Series B, we will be expanding the business team a lot. And also, of course, expanding the engineering side, because there are more verticals to get into, more use cases. Sky's the limit for graph technologies. And so our plan is to expand to about 250 people or so in a year and a half.
When you're sitting with candidates, talented people who you think can add value to Katana, what is it that you tell them about the mission, the journey that gets them excited to join Katana Graph or some of the other great options that are available to them?
Now, every company talks about, oh, this is the company culture and so on and so forth. You might be skeptical about whether we really have a company culture. I believe we do. And here is, I tell new recruits after they join the company, I talk with them for 15 minutes, and I say there are two things about Katana culture that I really want you to understand, and these are very important. Culture is, I think, a lot like oxygen, right? If it's there and it's good and so on, you don't even notice it, right? You were telling me that during interviews, you stay so silent that you're not noticed. Right? It's like oxygen. If you're doing your job, you don't notice it. You notice it when it's not there. Right? Mm-hmm. So what is the Katana culture? There are two aspects to it. The first is, I tell people very often, particularly on the business side, right, when they accept the offer, they say, we're very happy to come and work for you, Keshav. And I immediately tell them, at Katana, nobody works for anybody else. We all work but we're a team. And I want everybody in the company to think of themselves as a soccer team or a football team or something. Sure, you've got to have a quarterback, you have a captain of a soccer team. But once you're out in the field, you don't really say, I have to pass the ball only to the captain because he's the captain and so on. The goal, pun intended, and you have to operate as a team. So there's no hierarchy over there once you're out there in the field. You have to work as a team, and the goal is to win. So that's how I want you guys to think about yourself. At Katana, nobody works for anybody else. Nobody works for me. We all work for Katana. However, there's a chain of responsibility. So there's no chain of command. Nobody commands everybody else. The way that we make decisions is we sit around the table, we discuss, and usually when it comes to, for example, recruiting, right, there's a lot of agreement between people. And so in that case, I don't need to do anything. I just need to rubber stamp what the team is already telling me. In the rare cases when there is a genuine difference of opinion, that's when I need to step in and make a decision so that we move on. But that is how I see my responsibility. There is no big a CEO sitting over there, CTO, chain of command, org chart, and so on. There's a chain of responsibility. I'm responsible to my investors. I'm responsible to my customers. I'm responsible to the people at Katana, but there's no chain of command. So that's one thing I tell them. And, a lot of people enjoy. There are also people who have some difficulty adjusting to it because they're coming from a different company where it's perhaps very hierarchical and people are told what to do and so on. And so it takes them a little bit of time to get used to it. But I tell them, this is very important. You have to realize we work like. So that's one part of it, the culture. The second part of the culture is, I think, summarized by this Japanese word, kaizen, which you're probably aware of. I'm sure I'm not pronouncing it correctly, but that's how it's pronounced in the West. So we'll call it kaizen, which means continuous improvement, right? And I tell people that's a very important part of Katana, right? Because as a tech company, we have to take risks, right? The biggest risk of all is not taking any risks. So if you don't take any risks, you're never going to fail. But that is the biggest risk of all, because then you're just sitting over there letting external events drive you. So you have to be able to take risks. When you take risks, I'm very aware that you may fail sometimes. There is nothing wrong with failing, right? If you're not failing often enough, that means you're not taking enough risks. But here's the important point, right? It's okay to make a mistake, but you should never make the same mistake twice. So you have to learn from your mistake, improve yourself, improve the company. These are the two things that I want you to internalize as far as Katana culture goes. And what I found is people really like this. As I was telling you, it takes a little bit of time for some people to get used to the relatively free-flowing culture and not having, C-suite people ordering people around and so on and so forth. But once they get it, right, they seem to thrive in it. And I think that comes across to the people that we're trying to recruit. And I think it's also one of the reasons why we really have not lost many people, just two, as I was telling you.
The evidence is there. You've still got your entire team with the exception of two people. And from being here and hearing you talk about Katana Graph, the impact, the culture, it's easy to see why. It sounds like an exciting place to be for anyone who's interested in data, in AI, having an impact and working with good people. So, Keshav, thank you so much for coming on today, talking to us. Katana Graph sounds incredibly exciting, and you're just getting started. So we're very much looking forward to seeing what you guys, very much looking forward to seeing what you guys can accomplish. And I promise you, I'll come back again in a year or two and hear how things have progressed. So thank you again, Keshav. I really appreciate it.
Thank you, JP. And, doors are always open to you, literally and metaphorically. So please pick up the phone and come by.
Will do.
Thanks for listening to this episode of the Alldus podcast. If you enjoyed today's episode, don't forget to subscribe, rate, and review. We are available on Apple Podcasts, Spotify, and any Android podcast of choice. You can also head over to our website, www.alldus.com, to listen to more podcasts, view our open roles, and stay up to date with industry news. Thanks for listening, and stay tuned for more great episodes coming very soon.